Okay, guys, I'm sorry about that. We got interrupted. I'm not sure if I have fixed the issue or not. I am starting a recording, so if even if we get cut off, I can post a video later, but hopefully we can muddle through here. Sometimes, I don't know why, but some days are better than others, so I suspect it's my internet connection, but I'm supposed to have a good one. Okay, so here we go. So this function s equals negative 16t squared that we're given, that's supposed to be our position function. And notice that the position of the object is a function of time. So when that's the case, we can always find the velocity function, v of t, by taking the derivative of the position function. So I'm going to write down my position function, s of t equals negative 16t squared plus 224t plus 168. The derivative of the position function is the velocity function. So we're finding s prime of t right now, and that gives us the velocity. This is always the case. Oh, wow, this is really bad today. Gonna see. I'm gonna see if I can close a few things, see if it helps. I don't have much to close though. Okay, so to take the derivative of s of t, we're going to use the power rule. So negative 16t squared, the derivative is bring the 2 out front, so negative 32t plus the derivative of 224t is 224. Okay, and then that's our velocity function. And they asked us to find the velocity when t is equal to 3. So, sorry, adding 224 minus 96 is going to be 128. Okay, now it's on the velocity. It's just like miles per hour. It's distance over. The distance was measured in feet, and the time was measured in seconds in this case. So 128 feet per second. Sorry guys, this is really bad. I don't know why it's so bad today. Okay, so we've plugged t into the velocity function. So far that's all we've done. Now to find the maximum height, this is the same as saying the largest value for s, right? So we're maximizing a function, and when you maximize a function, you find the derivative. So we're going to find the derivative and find the critical values. We already found the derivative s prime of t. Remember, that was the velocity function, negative 32t plus 224. So if we want to maximize this function, let's find where that equals 0. By the way, this makes sense if you imagine an object moving vertically. When it reaches its maximum height, it stops for an instant and turns back around. So the velocity being 0 at that point makes sense. Anyway, solving the equation, we have negative 229 equals negative 32t. Dividing 229 by 32, we're going to get, let's see, we're supposed to give our answer as a decimal. That's good. So t is equal to 7.15625. So at 7.15625 seconds, we reach a maximum height. Now, what is the maximum height? So what plug into in order to find the maximum height, the position function. So they're really asking us to find S of 7.15625. All right, so S of 7.15625, we're going to have to plug into this quadratic function. And if you square it, multiply it by -16 plus 224 times 7.15625 plus 168, it should add up to 952 approximately. I actually think we plugged in 7 to get that. We rounded off. Okay, and then they also want to know what's the velocity when the position function is 0. So to do that one, we would have to figure out what at what time the position function is 0. So we're going to have to take S of t and set it equal to 0 and solve. So 0 equals -16t squared plus 224t plus 1. Okay, so this, we're doing the part that says find the velocity when S equals 0. So I've plugged in 0 for S in our position function. And we're going to have 0 equals -16t squared plus 224t plus 168. So you might recognize that this is a quadratic. 224 divided by -4 is -56. T minus 168 divided by 4 is 42. I don't know why this is happening. Yeah, I've restarted the live stream a couple times. I think I'm going to shut down completely and restart, so give me 5 minutes and I'll be back. Otherwise, you can watch the recording. Sorry, guys.